Now I move on to discuss how we come up with these three-phase ternary saturation plots. So what is this? So this is how we summarize any three composition model that sums up to one. So here, of course, saturation sums up to one. So we can use ternary plots to summarize these kinds of information. And how does it work? 100% of water saturation is right here. 100% gas saturation is here. 100% oil saturation is here. So because this is 100% water saturation, this line indicates 90% water saturation, 80%, 70, 60, 50, 40, 30, 20, 10% water saturation. And this will be 0% water saturation line all the way here. So I can give you this diagram or something similar to this in a quiz or exam and ask you, what is SWIR? Because you already see this line is what? 10% water saturation. This is 20% water saturation. This line is at the middle. So SWIR is what? 15%, right? We basically just started from 100, 90, 80, 70, 60, 50, 40, 30, 20, 10. Between 10 and 20 is 15%. And that entire line shows you the residual water saturation. So you are not able to reduce water saturation beyond this, which is why it's irreducible water saturation. How about oil saturation? Same deal. This is 100% oil. So this line is 90% oil. This is 80% oil. 70, 60, 50, 40, 30, 20% oil, 10% oil, 0% oil. And when it's 0%, you can have gas and water, but no oil. So what happens here at 20% oil saturation? That's the lowest. That's the lowest oil saturation you can have. You can't go lower than this. That's why you have that solid line there telling you this is what? SOR, residual oil saturation. But we don't really have a residual gas saturation. So gas saturation starts here at 100%, 90% gas saturation, 80% gas saturation, 70% gas saturation, 60, 50, 40, 30, 20, 10%, 0% gas saturation right here. Again, no concept of residual gas saturation because all of the gas can be dissolved in the oil or water, and the gas can, all we have when we deal with gas is critical gas saturation. So what are these colors now? So the region of interest really, if I were to shade it, is this part. Because it's bounded by this impossible zone of irreducible water saturation, this impossible zone of residual oil saturation, and really is this inner triangle where the oil and gas are mobile. The oil, water, and gas are mobile. So what do we show here? The relative permeability. So we are showing lines of relative permeability in here. And this is KRO of 0.5, KRO of 0.1 for this line, KRO of 0.2, and relative permeability increases down this way up to a value of 0.8. The equation for these lines are from the default eclipse model, which we showed here. So this equation basically combines different water saturations and you get the curved lines. What if you use the Stone's model 1, the Stone 1 model, which is this? This is what you get. So instead of those curved lines that span wider range, now you have straight lines as shown here. And again, KRO increases as you increase oil saturation, which is what you expect, right? Based on the curves, which we had looked at before. The interpretation of the 0 to 100% lines still is as before. Again, it's Stone 1, which is applicable typically for water wet rocks. When you have intermediate wettability, we tend to use Stone 2 model, which looks pretty much similar to that, but the positions of these lines are different, and the positions of those lines come from the use of this equation, which, like the other models, basically combine two relative permeability models, which is the relative permeability of oil water systems to that from oil gas systems. So you combine two relative permeabilities together and you're able to get your 3-phase relative permeability models.